We're going to start with DHCP, or Dynamic Host Configuration Protocol, as the very first application layer protocol that we're going to dig into, and I really chose that for a couple of reasons. The first is that DHCP is pretty common. You'll see it on nearly every network you go to. It's not used on maybe some really highly secure networks, some defense networks, maybe really small networks as well. But for the most part, we see DHCP in most places, and it's actually enabled by default on most off-the-shelf routers or gateways that you'll buy. So it's definitely very common. You're going to see it probably in your network, but also it's just really simple. It's a very simple representation of an application layer protocol, in that it's fairly static. It's not the most static of protocols, but it's very simple transactional protocol. It's got a few steps involved, and it's a nice introduction before we get into protocols like HTTP, which are certainly more common, and you're going to spend more time analyzing that, but it's also just such a wildly variable protocol with the different things it can include. So that's why we're going to start here with DHCP. Now, you may have heard of DHCP before because it's really responsible for assigning network addresses to devices that are connected to the network. So back originally, networks were very small, right? And you can manually assign addresses to any specific endpoint. So when you talk about IP addresses, those are network addresses that have to be assigned to a host. Everyone needs one to talk on the network or to talk to other networks. So smaller networks, very simple. You just manually assign those and configure those individually. But pretty quickly, as networks grew, that became not really the most feasible thing, right? You needed a way to automatically assign IP addresses to systems kind of in an automatic way. And you might say, okay, well, DHCP was the answer for that. And that's wrong. Actually, BootP was the answer for that. Well, that was the initial protocol that handled this. But BootP was eventually phased out for the most part for DHCP, which had quite a few efficiencies built into it. And now DHCP is really the protocol we use for that. I mentioned BootP because you'll see a couple relics of that within Wireshark when we go look at the actual packets. But DHCP is what we're talking about here. So it's used to dynamically assign addresses. Those would be configured upon a DHCP server, and the DHCP clients would run software that would allow them to go out and retrieve addressing information through a process we'll go through here in a moment. Now, it's not just used to assign addresses. It's also used to assign and provide access to other network devices. So it's actually going to provide addresses for things like the default gateway on a network, the subnet mask for a particular network, and DNS servers. So we're not just talking about taking an individual host and saying, here's your IP address, now you can communicate on the network. It's also saying, here's your IP address, and here's the IP address of a couple important things you need to communicate better. Obviously, you need a default gateway if you want to communicate to things on other networks. You need to know how to communicate to your upstream router. If you want to resolve DNS, which we'll talk about in a little bit, you'll need to know that DNS server address. So DHCP can be configured to provide addresses for things like this. Now, we're going to cover DHCP in a little bit of depth. We're going to cover the main processes involved with it. But if you want to read a little bit more about it, you can read into RFC 2131. This is the DHCP structure, and when you look at this, you might say, whoa, Chris, you said DHCP was simple. This is a ton of fields. And you're right, this is probably the biggest header we've looked at to date thus far. So when I say it's simple, I think it's simple in function, but the actual structure of the packet and the different fields included with it are kind of verbose, to say the least. So this is one of the reasons, and I include this in here just to show you how some application layer protocols like this look. This one happens to be pretty well structured. You can kind of see what's going on. But we also have a case here where a lot of these fields are just not used in certain types of communications. So that's one of the reasons we're not going to focus so much on structure here, and we're going to focus a little bit more on function just because of that variability. So I provide this here for your reference. I'm actually not going to go through every field. I'm definitely not going to do that now. We're going to talk about message types here in a second, but then we're actually going to dig into the normal function of DHCP and actually look at function. Again, I think that's where we draw the line for application layer protocols on what's practical and what's not. Again, I don't want to make this just a protocol lesson. You can read the RFCs on your own time or read a protocol specific book. I think that's useful things to know, but practically speaking, to get you off the ground, to get you going and analyzing the things you're going to deal with, it makes a lot more sense to focus on function rather than structure, which we'll do here in just a moment. Now, the one field I do want to focus on here is that if all these fields weren't enough, you see at the bottom we have the option for more options that can be included with the DHCP packet. And it's of interest that within options is how you actually determine what the purpose of the DHCP packet is. So we have what we call DHCP message types. And within the options section is when you generally define what the message type is. And it's that message type that determines the function of a DHCP packet. So I want to go through a couple of those message types, and that will lead us into a discussion of the different DHCP processes. So how a client goes out and requests an IP address and gets that from a server, what that looks like when it's healthy, when it's not, and so on. In this case, we have really 8 types of DHCP messages here, and I have them broken out based upon the number, the type, who it's sent by, and the description. So the number is the actual value you'll see in the packet. We'll see those here in a minute when we go through the actual packet examples. The type is the name of the message type. Sent by is who would send it, and the description is when that entity would send it. So remember, with DHCP server, we have, or DHCP protocol, we have the concept of clients and servers. A DHCP server is responsible for accepting connections and handing out addressing information. A client is just a host on the network that wants to receive networking information and would then request it from a server. So in this case, for instance, we have a discover, which is type 1. It's sent by the client to locate available DHCP servers. And we'll show you how we use broadcast traffic to do that here in a moment. We have the offer, which is sent by the server in response to a discover packet. You can kind of see a flow coming here, right? We have the request, which is sent by the client to request the offered parameters from the server, and so on. So we have a couple different options here. I'm not going to go through them all here. We're going to go through them when we go through the actual examples, but I do provide this chart for your reference so you can look back upon this when we talk about some of these examples, which are coming up in the next section, where we're going to start digging into normal stimulus and response and start looking at some packets.